Let's have a look at question 4. A swimming team sells t-shirts with their logo to raise money for an international competition. A survey into prices and predicted sales is shown in this table. The price of the t-shirt in euros is P. The predicted number of t-shirts sold is S. So you can see as the price goes up, the number of t-shirts sold goes down. A. Find the line of best fit that best describes the relationship between price and number of t-shirts sold. This is the demand function. Lines of best fit are covered in topic 4.3. Well, we'll do that here. So A. Okay, now what you need to do is to enter these in your calculator, and which I will do right now. Let's watch this video that explains the process. To put in the table, now to put in the table, you go to the table 1 here, click on that, and at the top here we're going to write P for price, and then we're going to put the numbers in 28. Then we click outside that, go over here to Control, Doc, and Add Data and Statistics. Click on that. We'd like to put price along the x-axis, so we click on that and choose P, and we're going to add S on the y-axis. Now that's as we'd expect. As the price increases, the number of t-shirts sold decreases. Now you've got a menu, Analyze, Regression, and Show Linear. Now the reason we do linear one, look, there's quadratic, there's cubic, there's quartic, there's power, is because it did look like a straight line, right? The line of best fit. So hit linear, there's 2 of them there, we're using the mx plus b. That one, and that's the solution there. That's the equation of that line as we expected. The slope is negative, right? So let's write the solution in terms of P and S. S equals minus 3.07 to 3 decimal places P plus 178. Let's now have a look at B. B. Determine the revenue function. Well, the revenue is just the price times the numbers sold. So that would be R equals P times S. All right. Now C, determine the t-shirt price that would maximize revenues. All right, well, so it's suggesting we need a quadratic, maximize revenues there. So now we're going to substitute this S here into this equation. All right. But revenue in terms of P equals P times minus 3.07 P plus 178. All right. Now it says determine the t-shirt price that would maximize revenues. So we're looking for the vertex of this. All right. So let's expand this. We've got minus 3.07 P squared plus 178p. Now you can do this one of either 2 ways. You could just find the vertex point for P, which was minus B on 2a, so minus 178 divided by that number times 2 there. Or you could find the roots of this and just take the midpoint. All right? The roots of this and find the midpoint. Okay. Now, they're both just as easy. We've already got this in this form, so we could just equate this part here to 0. And that will give us the value of P. Remember, using the null factor law, P is equal to 0. Or this term here, this part here is equal to 0. Let's do that one. Minus 3.07p plus 178 equals 0. P equals 178 divided by 3.07, which equals 57 57.98. Now remember that that's one of the roots. The other root is 0. Okay, because that is the root there, so that's 0. So the midpoint between 0 and this other root is 57.98 divided by 2, which is 28.99. So 28.99 is the p-value of the vertex, which maximizes this. So 28.99. Now, if we'd done it the other method, okay, using minus b, let me just do that up here, we would have known that the vertex point is at minus b on 2a. That would be minus b, and if we have a look at our quadratic here, we've got 178, that's b, so it's minus b, minus 178, all over 2 times minus 3.07, minus 3.07, and that equals 28.99. So that's no surprise that that method gives us 28.99, or finding the midpoint between the two roots does the same. Okay, it's 28.99 there. Let's have a look at D. D, determine the t-shirt price that would guarantee that no t-shirts are sold. Well, that's when this equals 0. Okay, we've already done it in C. Okay, we equate that to 0, and that will either be 0 or 57.98. So the answer there is $57.98. And again, the reason for that is that the roots of this quadratic are 0, right? Null factor law is 0, and when you equate that to 0, you get 57.98. So that's the solution.